So now let's go in depth into how we can actually write all the stuff. All and everything will hook upon the animator we've seen on the last part. If you haven't watched the last part or the first part, then you're going to have a lot of trouble with this. So even if it's a little bit boring, trust me, you have to absolutely watch it. Okay, with that said, let's talk a little bit about the controller. And let me just say that it's a little bit different than what we have done before. Now, you can see that this is our actual controller. The actual pivot is this. This is the actual collider. And this collider is only a capsule collider that has height of 1 and the radius is 0.5. Of course, you can actually use a sphere collider too. And this collider will only work for geometry. Okay, you won't have shooting, stuff like that and all that, then we will handle everything else with that different way, or basically using a ragdoll or something. We will see. Now, the capsule collider we have over here, it's not it's not touching the ground. So let's hit play and let's see this now. Okay, it's not touching the ground, so it's only basically on where the major mass of the body is going to be, because this way we can make sure that the collider does not get into the way when going into steep angles like that. Okay, and you can see that we have a few helper raycasts that helps us put this one into place. So just keep that in mind, this comes a lot into play. And we have this raycast is what places the actual what places into our own, or to the position we're going to be. And if I let me zoom in like this, and you will see that if I start moving around, then it looks like it has two raycasts, and that is because we actually do it the 2 times inside the frame. And oops, I was looking into this, so got lost over there. And we do that because we have to know, we need to fix the position after everything has done. After the animator has played, we actually need to fix the position so that we do not go through the ground, and we will see this in script how it goes. And now the other thing we have is a raycast forward to see what we have actually, there is forward. So if we run to a wall, we can stop. Okay, we can stop. And a raycast that goes not exactly forward, but what is next, so what we are stepping on next. So what this next raycast does is go over here. Okay, it finds the angle of what we are hitting on what we are moving next and controls the actual incline. So it's like this. And we also have a few more stuff so that we do not stuck whenever we are on air, and this controller does not stuck. So we basically have, if we are jumping, okay, it's only one, but as I said, one is from the one on the left is from the update, the call from the update, and the one on the right is from the late update call. Okay, and it does like a cross pattern. That's like this. And if it doesn't find something below, it looks for forward, back, left and right, so it can see if we are, if this has stuck somewhere, it will take it as on ground, and then you can move Otherwise you might stuck on some edge or whatnot. So let's put this back over here, and we are now ready to go into the scripts. So the first script we're going to see is our actual camera. Okay, a lot of the times we forget the camera, but let's come over here. It's something very simpler than we had before. So the camera rig is, as always, camera holder, which goes wherever the player is. The pivot is, how up, and basically where we rotate the camera from. The shaker is for if you want to have shaking the camera and whatnot, and the shaker is also the Z of your own camera. And of course the main camera is zeroed in under the shaker. Okay, so if you want to be up close, just change the shaker to go closer. But in this case, -5 is enough. So camera holder, let's open this. We're going to call this camera manager. Keep in mind of the namespaces. TPC stands for third person controller. I know, right? So call camera, add default as normal. We basically have, if you follow along on the previous third person shooter camera, then in that one we had different states of the camera, and we could change the pivot, the field of view, and all that depending on what the player has done. Now we're going to create that framework, but we're not going to see for the normal way. But yeah, we're going to reuse this camera script for other stuff too. So we have whole camera, add default as normal. Basically it's going to take everything you have from the editor whenever you start, and it's going to create a default case for the for the camera state. It's going to create a default state from what you already have. We're going to need all this, and that's redundant. Active state ID. Okay, serialize field, move speed, turn speed, turn spin controller, turn smoothing, speed controller, and lock cursor. References, pivot, and camera transform. What we need to know. State public camera manager is also Singleton, and you can use, instead of using get distance, you can actually use this. This is a Unity thing, as far as I'm concerned. Okay, you usually the way you create a Singleton is the other way around. Public static camera manager. Okay, instance, public static get, return instance. Okay, yeah, well, it might not be a Unity thing, but it might be a new C# thing. By new I mean a couple of years now. Anyway, it's the same like the way we are always doing it. Okay, use whichever one you prefer, but stick to one, because yeah, after my experience with Unit, I just rather create my own. Okay, so the Singleton, we assign this of course on awake, and we have target position, which is the target position we're going to go. The target position offset, in case we want to add any offset on that target position. This comes into play whenever on the third person shooter. This came into play when we had the the covering and looking from cover and all that. Some internal variables we're going to use: XY, look angle, tilt angle, offset X, offset Y. Okay, the smooth X, smooth Y, smooth X velocity, and smooth Y velocity. Camera state is a class, if you go to definition, it has the name of the state, an ID, the limits, minimum angle and maximum angle, pivot position, if you want to use the default pivot position, if you want to use the default camera Z, the camera Z, and if you want to use the default field of view and the field of view. Now let's go back again. Okay, we're going to create a list of camera states, even though we're only going to have the default state at this point. Camera state, the active state and the default state. This is, containers, so we know which one. We set up the default state in the beginning. Awake, and on start we create, we need to find the camera, the main camera. Okay, if you haven't assigned a camera, then you don't have assigned a camera with the tag main camera. From the camera we can take the camera transfer, which is the shaker. We never want to take the camera.main in this case. Okay, so we need the camera transfer, so that is the parent of the camera. The pivot will be the parent of the camera. Okay, so we go parent, and we create our default state, and that will be the ID will start as default. Minimum angle, maximum angle, we just set this to 35 and 35. The camera field of view will be whatever we already have inside our camera field of view. The camera Z will be whatever the camera transfer Z is, the local position of course, and the pivot position will also be whatever we already have on our local position, and we assign that into the default state. If we have add default as normal, the boolean, then we're going to add the camera state, we're going to add it, and we're going to change the default state ID to normal. We're going to set the active state as the default state, and we're also going to change the active state ID with what we have in our active state. We're going to fix positions. Fixed position is what actually gets and fixes, places the stuff we need to place depending on our active state. So we're going to start with the target pivot position. If it's set as use default position inside the state we're currently in, then we have, then it's going to get the default state pivot position. Otherwise it's going to set the pivot position of the active state. It's going to lerp into that position. Okay, local position from what it does, from what it has, to the target pivot position. Same with the Z. Okay, if you want to use the default camera Z, it's going to either use the default state or the active state, depending on what you have set. Target position will be, of course, we'll start with our own camera transfer local position, then it's going to get the Z, it's going to lerp the Z to the target Z, and finally it's going to apply it again to the camera transform local position, target Z. Okay, target field of view, use default. If you want to use the default, then you're going to use this, otherwise it's going to use the active state. Now the field of view should never be less than 1. Okay, if you have it set less than 1 or 0, then you're going to get an error in Unity. So this way you at least set it to something that is decent. And the field of view has to do with perspective basically. Okay, this is 1, this is what you see on field of view 1. So yeah, you do not want this to be 1 or less than 1. You cannot set it this way, but this is a range, so you can set it. And I actually do not remember if I had this at 60. Yeah, it was 60. Okay, you can set this through code through 0 to 0 and less than 1, but you cannot set it from the spectrum. This just ensures that you're never below 1. If you want to, of course, change to another limit, you can do it this way. And finally, you just lerp the field of view of your current field of view to the target field of view, and that is the with time.delta time multiplied by 5. If you want this to be faster, then just change the 5 over here. Same with all the other lerps. Okay, simple enough. We also have this, which I do not think we actually use this. Yeah, which does the same with for. Okay, it just gets the field of view and changes it this way in a while, just the same as the last thing we saw, but inside the coroutine. You're probably not going to need this. Now, get state goes into the list of states and it returns you the state with this ID. Simple enough. If you want to change the state, you will use this change state, pass the ID, active state ID. If it's not the same state we currently have, then it's going to use get state. Okay, if the target state is null, then you cannot find that state, so you're going to use the previous one, and it's going to change the active state, target state, and active state ID to this, and this will go back, and we'll go back basically into the fixed update where you have fixed positions on the end. Okay, this was on start, fixed positions, and if you have tick lock cursor, which on a final build you want to have this tick, so you have cursor lock state, cursor lock mode locked, and if you want to have the cursor visible or not. On fixed update now, if you have a target, then we're going to have our target position, we're not lerping yet, to be the target position plus if we have any offset. Then we're going to call camera follow, which it's a lerp between our own position and towards the target position. Okay, time to delta time multiply move speed, and the transform position will be this camera position, and this is how you follow around your player. If you haven't ticked hold camera, then you can actually rotate also. Fixed position, we've seen it, so I'm closing the fixed update. Okay, handle rotation. Handle rotation, the first thing we're going to have is handle offsets, and offsets are used for if you want to have recoil or your gun, you know, or something moving your camera around. Okay, you just simply add an offset, and this will just lerp this back into 0. So yeah, we use this for recoil basically. I don't think there was any other reason why I ever use this. Okay, it's very handy for recoil. Recoil, I mean, you know, the way Counter-Strike does it, because that makes your camera pop up a little bit up whenever you're shooting. Okay, handle offsets. We're going to get our two axes, and in this case it's going to be mouse X and Y plus any offset we have from inside the handle offsets, and we're going to use float target 10 speed is controller. I've actually made this up so you can use a controller to move the camera, but the controller to move, it needs to have a little bit more speed on the, you know, when you rotate. So if you tick is controller in the variables, then it's going to apply the 10 speed controller instead of simply the 10 speed. If the smoothing is higher than 0, then it's going to smooth it back using mathf smooth dump, and it gets, of course, we've seen this all the stuff before, smooth x, ref smooth x velocity, 10 smoothing. We will talk in a bit more in depth what the ref does later. Okay, smooth x, smooth y, otherwise set it like that, and the look angle will be we add on our look angle based on our smooth x multiplied by a target 10 speed, so how fast we are moving, how fast we are rotating. We reset the angles whenever we do a full circle. Transfer rotation will be look angle. Tilt angle, we're going to subtract from smooth y multiplied by target 10 speed. Okay, this handles rotation on the y axis, and this handles rotation, you know, up and down. Smooth y, okay, target 10 speed. Tilt angle, we clamp it based on what we have on our minimum state inside the active state and what we have on the maximum state on the max angle state. And we have local rotation. Okay, the tilt angle is going to be this. We basically assign it on the X for only a pivot. So yeah, so handle rotations is done. Handle offset, get state, change state, fix position, and yeah, as I said, we do not use this. So if I want to go and add a new camera state, let's say first, I will come over here. Okay, camera holder. I've already set up a normal one. Okay, let's create another one. Let's say that it's same, and let's use the same pivot position. The Z, you can use the same one, and if we want to change the camera field of view, let's change that into 45. And yeah, I do not actually have a way to go to a change state from the input, but right now, I mean, let's just keep it, and we will see this in a bit. You do not want to use default FOV. If we use the default one, then it was going to override this one. Okay, we will see this in a bit. Yeah. So let's save, and we've done with a camera holder. Again, the rig, pivot, shaker, main camera. Now, for the rest of the scripts, before you write anything down, just watch the whole video at least once. Okay, as I said in my other series, first watch the videos, then try to write something. Otherwise, you're going to have a lot of problems because we go from script to script with different references. Okay, and after all, this is our advanced projects, and you need to keep in mind, basically the idea behind it is you first understand the concept, and then you don't need to copy the script. You can write your own and, you know, interpret any way you can on top of it, and you create something that's actually your own after that. The basic thing you need to keep in mind is concepts. For instance, how we create camera states, we've already seen this concept, so you know how to create that, so you can go and make either your own or something that similar to this. Okay, just keep that in mind. And basically what we are doing in this channel is just seeing how many concepts we can handle, and all that in a game, in an actual game environment. So with that said, take my advice, watch all the video first before you write anything down. Now you see that we have our usual setup, state manager and input handler, and this is handy because if you want to do other stuff later, okay, then you can use the state manager to handle most of it. Let's see the state manager, but before we see anything else that has to do with this, we're going to see the variables and then watch a few other scripts. The model prefab, okay, they are our actual model if we are in game and if is player. This has to do with menus. They do not do anything at this point, except the is player, which is used inside the animator state behavior. Ground distance, ground offset, this will be 0. I have set it as 0 in the inspector. Ground distance is how much the ray that goes from the collider towards the ground it's going to be. Ground offset is after that ray has found a hit position, how much offset you want to add on top of it. Okay, this is just yeah, we do not need it at this point, but if you want to use it, you know, later, it's better to just have a way and not use it than not having any way at all if that occasion arrives. Okay, as I said, we tackle concepts over here, and we try to, with the concepts, we try to cover as much as cases as we can. Okay, distance to check forward is the recast that checks for obstacles forward. It also checks for some other stuff, but we're going to see what those other stuff are. Okay, it's how long that is. The running speed, walk speed, jump force, and airtime threshold. I do not actually know if those are the values. The values I'm using are these. Keep that in mind. Are not the ones I use over here. Okay, this is what I start with, but I tailor everything in the inspector. And run speed, walk speed, okay, jump force do not need any explanation. Airtime threshold is if we are in air, on the air for more than 0.8 seconds, that means we're going to play the other, either the hard landing or the rolling. Okay, just think it like this. Header, header, just puts something, a header in the inspector, anyway, ignore that. Horizontal vertical jump input has to do with inputs, as it says, and states is if we have an obstacle forward, if we have a ground forward, and our actual ground angle. Okay, state requests, and this updates other stuff and does other stuff inside the other scripts we're going to see. Current state, on ground, run, walk, on locomotion, in angle, move direction, if we are actually looking towards where we are moving, jumping, and if we can actually jump to. References, animator and rigid body, and the active model, and some internal variables, well, mostly internal variables. These are public, but we do not want them in the inspector because there's no point in overriding this, but we use the move direction in some other scripts. Okay, aim position, this shouldn't be over here. It's basically the same as the move direction. Okay, aim helper, current Y, current Z, it's, basically this started as a third-person shooter, but again as a third-person shooter, but I kind of think that doing it this way, doing an advanced third-person controller to work first, then tailoring it to be a third-person shooter is the best idea. And you're going to see some, I have a few surprises for the fans of the third-person shooter series I did, and trust me, it's going to be the best thing you ever seen. Okay, airtime, and if we are previously were on the ground, and our ignore layers, and we also have an enum which has idle, moving, on air, and hold. Basically has the states we are in. If we are on idle, if we are moving, it doesn't care if we are moving or if we are walking or running, all that. We only need to know only these cases: idle, moving, on air, and hold is whenever we want to not do anything basically and let the script run its course. Okay, so for instance, the first moments you are jumping, you do not want the logic that has you on the ground running, otherwise you're not going to jump. Okay, so we use this to control that. We can actually see the initialization phase too, so this is one is a little bit important too. Okay, on initialization, let's say that we are in game, we create the model, we instantiate whatever we have on our model prefab, we parent it under our own game object, we reset its rotation and position, and we set the scale to 1. With that said, you need to fix any scale problems outside of Unity. Okay, you should probably never have any object that doesn't have 1 scale inside Unity. Of course, that's that might not always be the case, but you should fix any problem with scales, even if it's weapons and all that. The good practice is to have that fixed. Okay, now if you do it or not, it's entirely up to you. Okay, so setup animator. After we have created our model, we know we can find an animator, and we're going to check for we're going to first get the animator, and the child animator we're going to have is we're going to get it from the active model. Okay, so we're only taking the animator that comes with the active model. We're going to get its avatar, and then we're going to destroy the animator we had over here, over there. Okay, and it works like this. And then we are free to add any controller references we have. So for instance, we're going to add a rigid body. We're going to set the angular drag to, something high, the drag to 4, and we're going to also set the constraints, rigid body constraints, freeze rotation Z and freeze rotation X. And this is the initialization phase. Now, before we see any of this, let's watch our other scripts. So for instance, how we update stuff in here. Well, we're going to go into the input handler, into our new script, which controls every handler we have or everything we need. Before we actually go to the input handler, we're going to go into a script that I call statics. And this is just a little quirk I have, and I'm going to tell you where this is useful. So, public static class, the whole class is static. Okay, and I have my hashes over here, public static string horizontal, and it's actually exactly the same: horizontal, vertical, special, special type, on locomotion, and even on on inputs and all that. Why I have it this way is because if I have somewhere where I set up a boolean inside the animator, and I think I have it over here, okay, this is wrong. It's not wrong that it's not going to play, it's because you have to create a new string every time, first, and second, because if you go and change the name inside the animator from the incline to something else, okay, then you need to search all your scripts to see where you use this. The other way you can escape that is using this public static string incline. Okay, and if we go back again, state manager, if I, instead of using a new string, I can go to say statics dot incline. Okay, and whenever we didn't say the statics, that's why we got the errors. And if I go and change this to something else, so incline with upper I, for example, I can come over here. I only have to change it inside over here. Okay, and then I do not have to go through all my scripts and look if I have the incline somewhere else. Okay, now I'm going to set it back into what it was because I actually do not know if I have it with a string or with anywhere else. So I'm going to set it back. Okay, you do not have to do it this way. It's just a little safer way, I guess. Okay, especially if you have to do with a lot of this and you have to change names a lot. And another thing you can do is also you can use this get animation special type, and we have an enum for all our animations or all our special animations. So for instance, run to stop, jump idle, run jump. So instead of having to remember every time that the run to stop is an integer of 11, so its ID is 11, you just have this, and what it's going to do is going to return you its value depending on the enum you select. Okay, so you do not have to remember any IDs, any numbers, basically. You just use this function based on the enum and you select the animation this way. Now, let's go back into the input handler. Let's close the statics since we covered it. We have state manager, reference to the state manager, that is. Camera manager, we're not going to do anything with it from the inspector, so we can close it, but we might need it inside handle movement player. Let's see if we need it. Yeah, we need it. Okay, handle movement player is a dedicated script that moves the player around. Float horizontal, vertical, well, you know what this is. We add the reference of handle move player, so this is what actually adds the script into our own controller. We get the reference for the camera manager. We assign the state manager and both the handle movement player. We set on the camera manager the target to be this transform. You're only going to have one player in your game. Well, in a single player game anyway. all the other, but yeah, even in multiplayer, still all the clients are not going to be using the same camera as you, so you only have one. We're going to take each player, which, as we said, it only comes into help at this point on very few stuff, but later on we're going to see other stuff. We initialize the states, so the states actually does not have any update or any start. Okay, so what initialize the state is the input handler. Handle movement, we also initialize this from over here. We haven't seen it yet, but we will see in a bit. And fixed player meshes, because we have skinned mesh renderers, and sometimes, let's for example add one of these of the other characters I have. Okay, if I select his face, sometimes, especially depending on the animation they are playing, the bounding box might be if the camera is too close to his face, or into any other part for that matter, or something, or his hat, like that. It might go away, but if his bounding box is outside the view of the camera, then it's going to cool it, and your player is going to see somebody that doesn't have a face that's really up close to his camera. To fix that problem, you need to go and tick update when off screen. Now, so that you do not have to do this on all your models, we're just simply going to write it inside the script. So we have this. So it's going to look for any skin mesh renderer you have under your player, and it's going to go and tick update when off screen. Okay, this is a third person controller. Doing this, of course, you have to understand that it requires a little bit more performance, but this is a third person controller after all, which means you're going to have a third person controller game, which means it comes with the territory to require more performance. On fixed update, we need to update the tick, we need to update the states from input, and then we need to move. Okay, so here is our execution order for all the scripts we have. Okay, we have we first update our current states, we then update the states from input, and then we move. And it's kind of important, otherwise you might get errors. You might not get errors with this, not errors, weird behaviors, you're not going to see errors in the console. Okay, there's a reason I have it this way. And yeah, and then you update the handle movement, you run the update. And by update I mean fixed update, and by fixed tick I mean the update. Okay, just keep that in mind, although that's probably a little bit annoying. Yeah, I know. Just change the fixed tick to something else inside the state manager. Okay, so on fixed update we're going to run all this, and on update it's basically all this does the behavior that looks if if there is ground below it. Then we call update states from input. We get our vertical and horizontal from the axis we have. Okay, statics, vertical, statics, horizontal, the two strings. Then we need to find the vertical and horizontal axis depending on where our camera is looking. So camera manager forward multiplied by the vertical is going to get us our vertical movement, our vertical vector. For the horizontal we're going to get the right of the camera manager transform, and we're going to multiply it by the horizontal. We're going to reset the y of both of these vectors to be 0, and the state's horizontal is going to be the horizontal we have on our input and the vertical we have on our input. Now we're going to find our moving direction, and that moving direction will be the h and v vectors we have over here, also normalized, and that is our move direction. So if there is no input, this means both of these are 0. If there is only one input, then a 0 in vector with an input, it's only going to return you one vector. And we update on our move direction, on our state's move direction. We update it with move direction, and then we need to find if we are actually the player is actually looking, or the character in the matter is looking towards where he actually wants to move. Okay, so if on the stage we have in angle move dir is true, how this is controlled? We have a function that returns us we pass a vector 3 and the angle. So if we go into this angle, okay, target direction and the angle threshold, it's going to start as false. It's going to find the angle between the on transform forward and the target direction, and if the angle is lower than the angle threshold, then it's going to be true. Okay, so it's going to come back over here and say in angle move direction. Now, if we are walking and the horizontal is not 0, and if we are walking and the vertical is not 0, so that means whenever we are walking, we're going to override this and we're going to say that it's true. Okay, so this overrides when we are walking. Basically, it was too slow if you were stopping and wait till you rotate towards where you're looking, and that's why I just override whenever we are walking. On locomotion, we're going to check inside on our states, and yeah, if this is true. And the way we see if we are on locomotion state is by using states anim get bool statics on locomotion, and you can see that yeah, practice what you preach. State jump input get button jump. Let's open the statics again, managers, statics. We already have a jump, but this jump is for the animator, even though I think I actually do not use, it's from an older version. So I'm going to set this to jump, and I'm going to capitalize this to jump, and change this statics to jump. Okay, simple enough. We have our in angle and we have our update states from input. So if we are on locomotion, we update from here. Handle run is controls if we are running or not. Again, with this, let's set this to public static string fire 3. This has to do with the input axis from Unity's own input handler. For basically Unity's own input. Fire 3. It's the Swift. So on run input, if you are holding the Swift key, then states.walk will be false and states run will be true. Else it will be the opposite. If horizontal is not 0 and vertical is not 0, and there is actually we update the states run to be whatever we have on our run input, and we're going to get to set the special type in the animator to be 10. If you remember, I should have used, instead of hard coding it to 10, I should have used get anim special type anim specials run. And just to be safe, let's see if that is the actual value. It's 10. Okay, because I created this and I know what values I've set on the animator, then there is no need to, I could hard code it, but this you should keep into something. If you're using something we created this to use it. Stick to that so that there is consistency inside your script, and do not be like me, be more organized. Basically, that's what I'm saying. Okay, if we states run, if we are not pressing any buttons and we're actually running, then it's going to reset the states that run to be false. Now, if we are not in angle and we have tick into the handle movement player to do angle check, basically, yeah, if you want to override the angle check, we're going to see what this does though. You should probably just keep it to true, otherwise there's no reason why you're watching this video. You will see what I mean. Okay, stage.run, then this will be false. If there is no obstacle forward, then you are not running. If stage.run is equal false, then you set the integer special type to 11, which is the statics get anim special type anim special run to stop, and let's make sure it's actually 11, and it is 11. Okay, run to stop and all that. Now, because to go into other states that are not inside this, even if they use special, the special should be true, and that's why we can control the special type without going into any states that are outside of this. Okay, just keep that in mind. Why I do not have set special to false, because we can also use that false to go into another state. So yeah, this is just a little elegant way to do all this. And from after this, yeah, we are at 46 minutes. We still haven't covered everything I want to cover. We need to cover the state manager and the handle movement player. Now, these two scripts can actually take about an hour because there is a lot of explanations. So let's see if I can cover anything else. Otherwise, we're going to keep that for the next part. And yeah, I think those two scripts are the last two things we need to see. So I'm going to end the video now. You know what to do. If you don't know what to do, then you're here to learn what to do. And if you like what we're doing, okay, hit that like, hit that subscribe. If you want to ensure the longevity of the channel, okay, and by that I mean if you want to help me out, keep making all this, then consider supporting me either on Patreon or, you know, on Gumroad, where you can buy, not pick, okay, a project or two, or 3 or 4, including this one, including a lot more other cool stuff I have, and I'll see you next time.